Good morning or good afternoon. How are you doing? As per your request, thank you so much for giving me some ideas of what videos to make. Today we're going to be practicing finding the area of shapes that are not perfect rectangles. So remember what we know already about rectangles. A rectangle has these two sides are the same length and these two are the same side length. So if this were 5, this side length were 5 meters, this side length would be 5 meters. If this were 2 meters, this one would be 2 meters. And we already know to find the area of a rectangle like this, what do we do with the side lengths? The 2 and the 5. We're going to multiply them. So I would write 2 times 5 is 10. So the area here would be 10 meters squared or square meters. All right, but today our goal is to find the area of shapes that are not perfect rectangles like that. You're going to remember that we did several steps to find the area. What were some of those steps? Think back. Before break and weekend and all that. First thing is we have to actually divide our shape into rectangles. So what are some ways that I could divide this shape? I'll give you a moment to draw on your own board. I could decide to draw it like this and make a rectangle here and one down here. Or I could divide it like that and have two rectangles like that. For the case of this example, I'm just going to go ahead and divide it up here. All right. So now, I have two rectangles, but in order to find the area of each of those, I need the side lengths. Is this rectangle, is this side length 7? No, this whole side length is 7. So I cannot say that this little part is 7. But I can use what I know here and here. So in order to find this side length, if I see the whole thing is 7 and this part is 3, then I know this part needs to be what? 7 subtract 3, which is going to give me 4 centimeters. Because 4 plus this 3 centimeters would give me a total of 7. All right. Do I need any other side lengths? I think I'm actually good to go. I have these two for this rectangle and these two for this rectangle. Now I need to find the area of each rectangle using my side lengths. Just looking at this top one, if I cover up this bottom one, how will I find the area there? I'll multiply 4 times 4. So I'm going to write that up here. I'm going to write my multiplication sentence. 4 times 4. And I'm going to add that to what? I have this one. Need to add it to the area of this one, plus 3 times 9. I'm missing something very important. What am I missing? I'm missing my parentheses to show me the order I need to do things. We're going to multiply before we add. 4 times 4, 16. 4, 8, 12, 16. Plus 3 times 9, remember we can do our 9s trick, so I can go 1, 2, 3, got that down, and I have 20, my 2 10s, and 7. Ooh, I don't want to mess that up, so I better do my addition over here. And I'm going to line up my place value. 7 plus 6, 13. I'm going to carry my 10s over there, regrouping, and I have 43. 43. What are my units? Centimeters squared. So the area of this whole rectangle is 43 centimeters squared. Whew, that was a lot of steps. Are you ready to try one? Another one? We're gonna change our side lengths a little bit, but I'm gonna keep my same basic shape. And we might partition it or divide it up a little bit differently this time. As long as we have those rectangles, then we are good. All right, so in this one, here we have 3 meters, 9 meters. We don't know how many meters over here. 4 meters and 6 meters. All right, so let's divide up our rectangle a little bit differently this time. Let's divide it here. All right, so now we have our 2 rectangles, but we're also missing some side lengths. So which side lengths are we missing? Let's see, we know this one is 3. Here's our rectangle over here. And we know this one is 4 because if I just look at this rectangle, the 2 sides that are opposite to each other must be equivalent. But I don't know this one yet. So if I know this one over here is 9, I know this one is 9, and I know part of that is 6. So the other part over here will have to be 9 subtract 6, which will be 3 meters. And over here, 3 meters. Now let's write our multiplication. We can either write it in here or on the side. So let's just look at this rectangle first. We know 3 times 4 is going to give us the area here. And 3 times 9 will give us the area here. So I can write 3 times 9, parentheses, plus 3 times 4. It's going to give us our area. We could even use a variable like we have before. That's going to even strengthen what we're doing. Let me move it over a little bit. I put a capital A since that's our area. So this is going to be 27 plus 3 times 4, 12. Now this time, let's add those up. 9, 39 is equal to A. So A 39 meters squared is our area. Great job. So this is just a review on how we can find the area of those shapes that are not perfect rectangles. Let's do one more, and I'm going to come up with this one too. All right, here's our shape. Maybe this is like some shape in my house and I need to find the area. And this side is going to be 13 inches. And this side is going to be 5 inches. And this one is going to be 5 inches. 5 inches. When I say that, that's this one right there, and 5 inches there. And this long one is going to be 7 inches. All right. Do you have somewhat of this shape down on your board? Let's think about what's our first step. Our first step is partitioning it into 2 rectangles, correct? So I don't think it would be very smart to partition it like this because then I'm going to have 3 rectangles. So let's partition it right there. Great. Now what do I need? I need any missing side lengths. Do I have any missing side lengths there? thinking, I don't know what this length is because I'm going to need that for this rectangle. Now notice we have a 13 over here. So this whole thing is going to be 13. So if I know the whole thing is 13 and part of it is 5 and part of it is 5, if I do 13 minus 5 minus 5, I'll know this one. So what's 13 minus 10? It would be 3 inches. And over here, 3 inches. See how I did that? If I add 5 plus 5 plus 3, I get 13, which means this is 13 and this is 13. Okay? Ooh, now we're ready. But I see something pretty interesting. 13, is that a very friendly number to multiply? Not really. So how could I even make this one more rectangle in here? Or even partition it one more time? I could partition it by saying 13. I see that's made up of 1 10 and 3 1s. So if I partition it like this, and I have 3 inches and 10 inches, then I have 2 rectangles, which will be easier to find the area of because I don't know 5 times 13 right off the top of my head. That's kind of hard. All right. Looks like we have a lot of numbers, but we're ready to find our areas. So, where would you like to start? I'm going to let you find the areas of some of these. Make sure you're showing your work. I'm going to start over here. 3 times 7 is 21. 7, 14, 21, or 3, 6, 9, 12, 15, 18, 21. So I have this rectangle. Now 10 times 5, ooh, that's easy. I know 10 times 5 is 50. And 5 times 3 is 5, 10, 15. 15. Now I have 3 different areas. So that was the way I did the distributive property basically by saying 5 times 13 is equivalent to 5 times 3 plus 5 times 10. 5 groups of 13 is the same as saying 5 groups of 3 plus 5 groups of 10. That would be the same, but just shown here with an area model. All right, now we're ready to find our complete area. So I'm going to add 50 plus 21 plus 15. 6 units, 7, 8. So if I add all of these, I should write my multiplication with my parentheses. 10 times 5 plus 3 times 7. We could do a different area. Maybe I'll do a T this time. Oops, hopefully you can see that. 15 plus 50 plus 21 is equal to T. And when I added those up, I got 86 square inches is our area T. Great job today on doing those steps to find the area of shapes. And I look forward to seeing your work.